Excellent. Thank you. Welcome, everyone. This is the final of the series from the fall of 2024 in the Careers in Technology series. We have Khandakar Nusrat Islam, PhD, who will present her work to us. I want to read a little bit about her after I review our current status and our previous events. As you are aware, whoops, I'm having a little trouble with my slides here. There we go. Okay. So this has been the fall series 2024 of Careers in Technology, sponsored by IEEE, IEEE Computer Society, and IEEE ComSoc, funded and founded by Computer and Communications Joint Society, Northwest Florida, IEEE Northwest Florida section. These are the series that we've already had this fall series, which includes Professor Dr. Victor Lawrence, Professor Dr. Paul Berger, Florence Hudson and William Harding, PhD, Mr. Al Spuntoff, and this is our final in the series of the fall, which is Khandakar Nusrat Islam, PhD. And I hope you'll look to our recordings for sharing with your friends, for reviewing the meetings, and for ideas about future sessions. Please remember to subscribe to our series. Please write to Michael Viren to add you to the list if your section or chapter is not yet a member. Let me go back to the picture and I will introduce our speaker. Khandakar Nusrat Islam is an RF microwave solutions engineer at Keysight Technologies, where she excels in both engineering and project management. Specializing in RF solutions architecture and project oversight, Nusrat is instrumental in developing custom global solution delivery next-generation solutions at Keysight Technologies. Dr. Islam earned her PhD with distinction in electrical engineering from the University of New Mexico in 2022. Her groundbreaking research on high-frequency traveling wave tube amplifiers resulted in a patented technology reflecting her significant contributions to the field. She also, yes?
Sorry about that.
Oh, no problem. She also holds an MS in electrical engineering from UNM in 2017 and a BSc in electrical and electronics engineering from Eastern University. Her remarkable achievements have been recognized with several prestigious awards, including the 2022 IEEE Nuclear and Plasma Sciences Society Igor Alexev Award for Outstanding Student in Plasma Science, and the IEEE Outstanding Young Service Award from the Albuquerque section. She was also honored as the Outstanding Graduate Student in the Department of Electrical and Computer Engineering at University of New Mexico. Dr. Islam's career in technology is crucial for driving innovation and addressing pressing global changes. Her work in developing cutting-edge solutions at Keysight Technologies not only advances engineering practices, but also enhances connectivity and improves quality of life. By driving technological progress, she contributes to transformative breakthroughs that benefit industries and communities worldwide. Beyond her professional achievements, Dr. Islam is an active contributor to the IEEE community. She also served as the Women in Engineering Affinity Group Chair from 2019 to 2022 in Albuquerque, New Mexico. She is currently involved in several initiatives aimed at promoting diversity and inclusion within STEM fields and is spearheading projects to mentor and support the next generation of engineers. Outside of her professional life, she is passionate about traveling, volunteering, and community service. Her interests also include hiking, cycling, cooking, and creative pursuits, such as writing poetry and journals. I'd like to introduce Nusrat to you, and she'll fill you in on her more recent achievements.
Thank you. Thank you so much for the warm introduction, Kate. I truly appreciate your kind words and the opportunity to speak today. It means a lot to me.
I'm very grateful that you could join us. You welcomed me and our entire team when you were running the organization over in Albuquerque, and I really appreciate it. It came at a wonderful time. It gave us a lot of encouragement and inspiration to move forward with our projects that we were doing with women in engineering and also the humanitarian technologies, and in addition to our standards. So you've been part of the work that we've been doing here for a very long time. So I'm really grateful that you have a chance to be here as a guest.
Thank you. Thank you again. Should I share my screen?
Yes, please.
Sure. Okay, I hope everyone can see my screen.
Looks good.
Okay. Well, thank you again for nice introduction. All right. A little background of me. So I earned my master's in 2017 and my PhD in 2022 in electrical engineering from the University of New Mexico. And before that, I completed my bachelor in 2011 at Eastern University in Dhaka, Bangladesh. For my master's thesis, I focused on methods to remove surface charge. And in my PhD, I researched how to generate multiple beams for application in traveling tubes. Right now, I'm working as advanced solutions engineer at Keysight Technologies. Before this role, I was a postdoctoral fellow at UNM and interned at Los Alamos National Laboratory. I also worked as a teaching assistant at UNM, research assistant as well, and spent about 3 years as a government electrical engineer back in Bangladesh. I have had chance to work with IEEE Women in Engineering in Albuquerque, New Mexico, where we support and empower women in tech. I have also volunteered with other IEEE projects and served as a STEM judge, which has been a great way to encourage young minds in science and engineering. It's really been, a very rewarding experience for me. Okay, so my journey in tech began in a very small town in far north of Bangladesh, as you can see on the map. I left my hometown at 16 to move to the capital for high school. After finishing college, I landed my first job as a government electrical engineer. Then I decided to pursue my higher studies in the USA, crossed Atlantic Ocean, leaving everything behind me. My family did not support my decision as my job was, prestigious, secured in my back home. But I traveled alone on this journey, which has continued to this day. Initially, my plan was to earn a degree and, to get a promotion back home, aiming for a secretary level position. However, after completing my PhD, I realized there were not many relevant job opportunities, especially in tech industry in Bangladesh. So I chose to continue my career in tech. Now the USA is my third home, and I'm excited about the opportunities it offers in my field. So I feel really lucky to have gotten into the high power microwave research field. My professor, Idil Shamilagu, who was like a father to me, as you see on the left here, gave me incredible opportunities to work on some fascinating projects. He is well known in the high power microwave community. And here, as you see in the left, he's touring in the lab with the senator from New Mexico, who is also an electrical engineer. On the right, you see the Sinus 6 electron beam accelerator. I'm looking with my coworker. This Sinus series accelerators were developed by High Current Electronics Institute of the Siberian branch of the Soviet Academy of Sciences to perform some practical applications like HPM generations. And the Sinus 6 is a model of Sinus accelerators that was built for Professor Shamilagu at UNM in the early 1990s as a collaboration between researchers at the ACEI and UNM. So this accelerator can produce 10 to 15 nanoseconds duration electron beams. The common principle of these accelerators is quick release of streaming charged particles as a form of energy that propagates downstream in the drip tube. The main components are, the charging device, also known as Tesla transformer, energy storage capacitance, which is basically a long oil-filled coaxial cable, also like pulse forming line, and high voltage 2 or 3 electrodes, spark gap switches, tapered transmission line, and a vacuum diode. I'll explain that in a bit later. And this vacuum diode is basically a cold explosive emission cathode or plasma cathode, and it can be a planar, coaxial, or conical diode immersed in a strong magnetic field. So this research work at UNM, this is my PhD work, as you see in this Synapse 6 accelerator. So our goal was to generate 2 electron beam from Synapse 6 accelerator powered by single power. So multi-stream electron beam generation actually has recently been a great interest, especially in high power community, for enhancing efficiency, possibly where there is a 10 to 20% energy difference with comparable currents. And then we wanted to observe super exponential growth rate and then develop for high frequencies in the terahertz regime. And then, of course, high efficiency and long lifetime are extremely crucial for dropping wave tube. For example, satellite dropping wave tube transmitters. And no single study exists which describes a multi-beam traveling wave tube amplifier that is powered by 2 cathodes on a single cathode stop. I'll explain that, what I mean by that. At a single potential generating 2 electron beams, which can produce 10 to 20% energy difference and comparable currents. Okay, let's dig down a little bit of background. I'll try to be faster as much as I can because I have a lot I want to share with you. Okay, so the traveling wave tube first came to the limelight. I know all of you already know about this. At the end of World War II, introduced by Dr. Rudolf Kompfner, an Austrian refugee who was involved with British Admiralty at that time. The very first traveling wave tube, helix prototype was introduced by G.R. Pierce, as you see here at Bell Laboratories in the USA in 1945. And the application of this helix prototype traveling wave tubes was mainly for communications, like for satellite relays. And then later, different types of traveling wave tubes, broadband, narrowband, coupled cavity traveling wave tubes are also developed. And the helix traveling wave tube started being widely used for broadband electronic countermeasures and multi-beam ECM transmitters. Later, narrowband helix traveling wave tubes are primarily used for satellite communications and broadcasting systems. So this is the very first two-stream amplifiers were proposed by Pierce and Hive at about the same time. The Pierce design was, a two-stream driven amplifier installed with 2 separate coaxial tubular cathodes connected to separate power supplies, as you see here. The theoretical study shows this device is effective for low voltages. I guess it was in the order of 1 kilovolt connected with 2 separate power sources, and the Hive design was the same. As you clearly see that both designs are for low voltages and used for 2 different power supplies, which is completely different than ours, which I'm going to show you next slide. Okay, so this is the novel design was developed at UNM. This is my PhD work where you see a single cathode powered by 1 power supply. It's called MICD. MICD is a terminology meaning magnetically insulated coaxial diode. It is a popular term dating back to the Soviet Union, and it describes a coaxial cathode immersed in an axial magnetic field along the tube. A simplified analytic model was developed by Fedosov et al. And and this simplified design actually was allows us to determine the current voltage characteristics of an MICD, basically by ignoring electron motion in the acceleration region. And as you see here on the left, this is the novel design developed at UNM. The inner emitter is extended beyond the outer emitter. So, oops, I'm sorry. Okay, there you go. Yeah, my mouse is like acting weird. So, yeah, so the inner emitter is extended beyond the outer emitter, and then the bound. So as you clearly see here, the boundary conditions are not the same for both emitters L and Z, right? So there's, we applied another boundary condition here in the plane Z2 at the end of inner emitter, and then the XL axis of the T from Z1 to Z3 is divided like into 3 cross sections. Oops, I don't know why it's acting so weird. And then we can solve the system of equations by applying these 3 boundary conditions along this Z axis. Okay, so this magnetically insulated coaxial diode, this is for single cathode developed by Fedosov. I'm just going to quickly describing here. I'm not going to dig down the details. As you see here, he applied for 2 boundary conditions at the anode and at the cathode, and then he solved the system of equations. And then, as you see, the analytically calculated Fedosov current and energy for applying 400 kilovolt voltage, and then for a certain radius, I think it was 0.9 centimeter. And this is, again, I'm just gonna, overview. This is the mathematical calculation. So we took the Fedosov solution, the one I just showed you last slide, and then we extended this mathematical derivation, and we applied the boundary condition, and we solved the mathematical expressions. And then these are all the characteristics of multi-beam generations and how we solved this. And then finally, this is the hypothetically we analyzed and we optimized the design. And this is actually a brilliant idea from my PhD supervisor, because as I said, there is no exist research on this topic or on this problem. So my advisor proposed that why don't we start in the middle of in the cathode, as you see here, the inner cathode and the outer cathode. So we decided to put the inner cathode in the middle of the outer cathode. So the radius of the inner cathode would be half of the outer cathode, and so on. And the second one is 1/4 of outer cathode, and the third one is 3/4 of the outer cathode. And also we decided to increase the inner length of the inner conductor by 2.5 millimeter, as you see in this figure. All right, so this is the fabricated cathodes. Among other types of cathodes, cold emission cathode is found to be effective and most useful for high current accelerators. Typically, a coaxial diode is used in experiments for high power microwave generation. And the thickness of these annular explosive cathodes is very, very thin. This thin emitting edge usually generates electron beams with sufficiently high electric field distance on the electrode surface, about 10 to the power 7 volt per centimeter, that cause explosive electron emission. As you see, different types of materials can be used to generate high current single pulsed electron beams. And it is found that the graphite explosive emission cathodes show the best performance in experiments. So that's why we used these graphite cathodes. All right, so this is the money slide. This is the comparison of analytics and simulations of current energy as a function of the inner cathode radius. As you see here, we applied just a very short summary. we applied a single cathode voltage, which is 400 kilovolts, and then we applied different inner cathode radius, which is you see in the plot. And then by optimizing the cathode radius and cathode length, we found the sweet spot where the current and voltage meet together at certain radius, and that's where we found the energy difference. And this result shows you same results, but by applying different magnetic fields. We wanted to see how that magnetic fields impact to get the energy difference between two cathodes. The electron beams are produced from two cathodes. All right, so transition to industry. So I would appreciate if you turn off the recording now, please, Kate.
I did see the picture. I did see the pictures of the quantum computer. So I would probably like her to tell me how quantum computing works, but I but I won't do that right at the moment.
Okay, so at some point in the future, maybe we can invite Nusrat and we'll have a little meeting where she can help us understand more about quantum computing.
Sure.
I knew you,
quantum computing is not my field, but yes, I would definitely help you to have understanding actually what we do.
Well, you know what, I've attended some previous talks, and so most of the qubits look like diodes operating at cryogenic temperatures and being driven by 5 gigahertz signals. And so they presumably have, I don't know if that's a proper generalization, but that's, I think, where your equipment comes into play, is both driving and receiving that signal.
Okay. Yeah, since we do have time, I probably would like to show you some of our, equipments. These are the best in class solutions we do have. These are, we do have simulation software, we do have network test, we do have network feasibility, network analyzers, oscilloscopes. I'm pretty sure all of you are well familiar with this. You guys are working on that, and then, as I said, these are the key markets and applications for us. We work closely, and help innovators to connect and secure some test measurements and any other problems in aerospace, defense, communications, and so on. You see here medical, education, government. And then in aerospace defense solution, we do have government network operators. This is field fox. I work on this field fox very, very much. I work on this RF sensor signal, and then all these equipments. We do have some communication solutions. These are also field operation, spectrum analyzer. I'm pretty sure, I don't know if any students this year, they probably work a lot this spectrum analyzer. Yeah, we do have other automotive and energy solution. I believe I'm looking forward to show you, David, if we do have some quantum computing equipments also in my slides. So anyway, so PNA, I'm also sure if there is any student, they also use this PNA a lot. My sister is also doing her PhD. She uses network analyzer a lot also. And yeah, these are all the Keysight equipments. Since I have time, I just wanted to share with you guys. So
thanks so much. I appreciate it. And
yeah, sure.
So I think we'll mark down David's question because it's something others have been asking about as well. And for another presentation, we'll try to organize some more of a presentation specifically focused on the quantum aspects, and then that would be really great. So
we have some quantum computing expert actually, so I would be happy to bring someone really expert on that who has been working actually. Our Keysight Cambridge office, the manager, he has PhD in quantum, so yeah,
that would be wonderful.
That'd be quantum computing group. So
Yeah.
Could I ask where are you working? Where's your facility?
I work in Santa Clara, California.
Oh, you're in Southern California. The reason I ask is Keysight, of course, is a major employer in Colorado Springs.
Actually, I was hired first in Colorado Springs.
You work what?
I was hired in Colorado Springs first.
Oh, okay. You started there. Okay, great.
Yeah, I started in Colorado Springs. And it's a very small city, and I love there. Yeah, so we have a pretty big facility there in Colorado Springs.
Yes, yeah. For many, of course, Hewlett Packard, many of the Hewlett Packard facilities were located in Colorado,
That's true.
after its founding in California.
Yeah, yeah.
So now Nusrat is living on the East Coast, right? In Boston area now, is that right?
Yes, yeah, that's true.
Okay.
So she'll be able to come down to some of our events, and I'm sure over time we'll. I'm really very grateful that Nusrat was willing to give this talk so early in her career, 2 years into working at a company of
Yeah,
this,
this is my.
you know, and so there's a lot that she has to learn about her company and the field and all that, but she's confident enough to bring us her point of view so far, which is really wonderful. And yes, and one of the things that I really wanted to ask you about also is, do you get a chance to meet other mentors? Do you get a chance to mentor others? Do you find that you learn from one another on this job? Because it looks very exciting from this point of view.
Yes, that is a great question, Kate. Thank you. Actually, yes, I do have one mentor besides my own manager. So Keysight has a great policy, and I love that. I'm not sure if other companies do have this. So when I was hired, I was given another mentor besides my group. And I have been working with other mentor for last 2 years, and he's making sure that I'm on the track, and he's making sure my mentor is making sure that my what I really like to do, and if my talent, my skills are utilizing my current group or not, or if I can be, my interest is somewhere else. So I love that. So that's I'm working with other mentors as well. Yes. So
That's
yeah, that's the Keysight has this excellent benefits that I can explore other opportunities within the company based on my interest, and then based on through this mentorship.
And also, I guess you're getting to learn what other people's specialties are, since you know about this other person.
Absolutely, because I did not mention in my slides actually. Yeah, so I have been learning ADS, like Keysight software, EM Pro. Those are not heavily used in my group, but just because of through that mentorship, I am able to learn those two softwares. Those are very demandable softwares in today's market industry. So I'm learning them a lot. Yes.
That's wonderful.
Yeah.
So it makes the employer much more attractive to all the employees when you have that. Yeah. And
So
then you
for
can
this,
even.
okay.
Yes, Li Fang, please.
Yeah, I have some question about these instruments. So for this instrument, are these instruments suitable for both beginners and advanced users, or is the additional training required for the specific users?
Yes, I would say, I think I mentioned in my slides that we do have Keysight support here, and we do have professional services. So if any beginner wants to use these instruments, of course, these instruments are $1 million, like thousands of dollars. Some instruments are $1 million. So definitely, Keysight is there to support and help how to start. And we have the manuals, and we do have professional services. We do have training. So any beginner can use these instruments with the help of support and training.
I see, I see. So how about the data analysis? Is the data analysis integrated with this test software, or is additional software needed for the complex analysis?
Yes, so for the data analysis, we do have Keysight test automation software. That's a separate software. So yes, that needs to be integrated with the Keysight hardware. And we do have dedicated software architects team who can help you to integrate hardware and that software to do automation test and data analysis.
I see, I see. So one more question is about the text automation. So what types of the text automation can the software handle? Is it the customizable for the specific applications, or it's just a general application related to the test automation?
It's basic, general, complex, more complex, and then hybrid. Like I showed you one example from NASA. So it's not just a general automation. Like we do have customized, as I said, we have dedicated software team. They can customize, they can build customer solution based on the problem. Of course, everything is not, I mean, we try our best, I would say. It's definitely not guaranteed, but so far we have been successful. Any problems that customer asked us to do.
I see, I see. Thank you very much for all this information.
Sure, you're welcome.
So is in your fields, Nusrat, do you have the opportunity to have open source solutions as well, or do most of your clients really want proprietary solutions? I noticed you have some ISO standards you mentioned there. So is that mostly for the hardware and safety of the devices, or is that also for transferring data and stuff like that?
Yeah, that's another great question, Kate. Thank you. So yeah, we do have open source solution. Definitely, we do a lot of hardware solutions, but for the software, we have our own proprietary. We would like to have that, but we also offer customer to customized software solution. Let's say that we have already built up Keysight software automation, so customer can purchase that software and they can modify, or we can help them to modify that software system. But yes, but it's like open source, definitely.
Very cool. Thank you. Does anyone else, Michael, are you still with us? Sharon, anybody else? Anyone else have a question for our speaker? I want to, can we stop sharing and we can just see everybody on the screen? What do you think?
Yes, I can share, stop sharing.
Excellent, very cool. Okay, so I just wanted to say thank you to everyone for joining us and for participating in the conversation. Yes, right? That's very good. Yes, very, very good. And I want to thank you, Nusrat, for being brave enough to be our final speaker for this fall session and for joining us. Tom, yes, thank you. Tom, do you have any questions of our speaker?
Well, I don't have any important questions, but I was interested to see the little history there of
oh yes,
wave tubes, because that came out of Bell Labs.
Let me send you the link right now, otherwise I'll forget. Yeah,
yes,
thank you.
The link, yeah, the link of the video. And
yeah, the link of the video would be good.
Yeah. And Tom often talks about the traveling wave tube. We're big fans of Rudy Kampfner and John Pierce, of course. You know, it's a big thing around here to talk about their history, and it's nice to know that there are others who share that history. Excellent. There, thank you.
I just posted. I'm not sure if you can open that. Maybe you can try. I think you can.
And I hope everyone will subscribe to the next season's talks and share the word with others. We will have a program built very soon, and we will send information about all the people that you will meet in our next semester. So thank you so much for joining us tonight.
Thank you. Thank you
Yeah.
everyone for
Yeah,
joining.
thank you.
Thank
Thanks
you.
for having me.
Thank you.